Okay, well, good evening. I'm Margaret Hamburg, Peggy to my friends and CFR colleagues, and I'm really delighted to be able to chair, I guess, moderate this evening session. I think it's a very exciting topic and a new enterprise. I'm a member of the Council on Foreign Relations Board, and I'm also the co-president of an organization called the Inter-Academy Partnership, which is a consortium of about 150 academies of science, medicine, and engineering around the world that's committed to trying to strengthen the role of academies in providing science-based data for decision-making and sound policy-making. So the topic of this is very much part and parcel of what I do every day, but I think we have an exciting opportunity to extend our thinking and our reach in this evening's discussion and moving forward with this new program here at the Academy on the interconnections of science and foreign policy. This is actually the inaugural convening of the Norman E. Alexander Family Foundation Forum on Science and Foreign Policy. It's really, I think, a very exciting new addition to the Council's rich agenda of endowed annual events, and the forum was established specifically to explore the interconnections among the natural sciences, emerging technologies, foreign policy, and national security, and to do so in the context of uncertain times. And on behalf of the Council on Foreign Relations, I really want to take this opportunity to thank Dr. Mark Alexander, a fellow physician. It was really his vision and generosity that this forum has been put together in honor of his late father and in recognition of Norman Alexander's lifelong engagement in all manner of discourse for the betterment of humanity. So it's so terrific to have you with us tonight and to have your ongoing insights into how best to use this forum. This is an opportunity for us to really address issues of interdisciplinary knowledge sharing among scientists and foreign policy experts, leveraging the Council's convening power, and really trying to bring together critical issues for all of us at the intersection of science, technology, health, and foreign policy, and really the recognition that almost every one of the major and pressing problems before us requires understandings and application of science and technology to find meaningful and sustainable solutions, but that we won't be able to harness the power of science and technology today if we don't work in the broader context of foreign policy and international engagement. So we I think, can all recognize that science and technology plays a critical role in tackling the challenges before us, from climate change to energy issues to food security, global health, and beyond. But often science and technology is viewed as a distinct undertaking from the world of foreign policy. So it's great to bring together these important fields. And obviously there's interest here, and there's, I'm told, about 200 people on joining us virtually. So that is impressive to me. Unfortunately, one of our panelists for today was not able to join us, Priya Narang, and it's Priya, she goes by Narang, and it's too bad because she would have been able to discuss a really important and interesting and timely area of science and technology, quantum computing. But we are very fortunate to have two really outstanding and impressive panelists. And our panelists are both part of a program that the State Department began, I think now a little more than 2 decades ago, to really recognize this intersection of science and technology and foreign policy, and to create a program of science envoys. And actually this year, 2024, is the first cohort of that's all female scientists, and that's an important advance. But what is even more impressive than that is the quality and accomplishments of the scientists that are part of the Science Envoy program. We're really going to talk about the Science Envoy program and then talk about the context, the scientific context and the geopolitical context in which they're doing their important work. I think you have in this handout their bios, which are long and impressive. I'm not going to try to go through them all, but I do want to give you some sense of who they are and what they do before we go into the discussion. Dawn Wright, immediately to my right, is the chief scientist of the Environmental Systems Research Institute, or ESRI, which is a company that's a world leader in geographic information system software, services, and spatial data. She describes it more simply as, I think she makes maps, but it's really pretty complex. She's also a professor of geography and oceanography at Oregon State University, and she's an elected member of both the National Academy of Sciences and the National Academy of Engineering here in the US, which is a really pretty small and special club. And she's also an elected member of the American Academy of Arts and Sciences, and she has served on all manner of committees and advisory boards, and of course now is one of our U.S. State Department science envoys. Our other, and her area of focus is around climate issues and oceans in particular, and I'm told she often uses the moniker Deep Sea Dawn. Is that true?
I was given that moniker.
You were given that. Our other panelist is Stephanie Diem, who is an experimental plasma physicist and fusion energy researcher who studies innovative methods to heat plasma to temperatures that are 10 times hotter than the sun, and then tries to bottle it for fusion energy development. I'm not going to try to explain to you what that really means, but she may give us some more enlightenment on that. She is an assistant professor in the nuclear engineering and engineering physics department at the University of Wisconsin in Madison, and she also works with a number of companies around issues of fusion energy systems. Really, her focus has been working on developing strategies to reduce the cost and complexity of future fusion energy systems, which is so important as we think about our energy futures and a safe, secure energy supply. And she's also been a leader in critical interdisciplinary work to address societal, environmental, economic, and technological impacts of fusion. So I think you can agree with me that we're very, very fortunate to have these two individuals to begin our discussions around the intersection of science and foreign policy. I thought one way to get started would really be to focus in on the Science Envoy program. And as I said, it was started by the State Department back in 2010, I believe, and really was to select eminent scientists and engineers who would leverage their expertise and their networks to forge connections and identify opportunities for sustained international cooperation. Science envoys have been selected every year, and they focus on issues of common interest in science, technology, and engineering fields, and usually serve for 1 year, although I understand that it can be extended. And they're really instrumental in strengthening some of our bilateral science and technology relationships, reaching out to foreign publics, as well as government officials and scientific counterparts, and advancing certain policy objectives. and advocating for science-based decision-making. They work peer-to-peer, they work with scientific institutions, they work to promote scientific education and public engagement, and advising the US government on critical issues in global science. So with that, I will stop talking, and I will turn perhaps first to you, Dawn, to just give a little bit of background about the work you do, how you came to it, and importantly, your role as a science envoy.
Well, my background is as a geoscientist. I am trained as a geologist and a geographer. And I also do quite a bit of work in terms of mapping the environment. And the company that I work for, the Environmental Systems Research Institute, or ESRI, is one of the world leaders in providing maps horizontally across all disciplines, across all uses, across all sectors. So we do a lot of business, or we support the State Department, we support all branches of the US government, probably around 200 other world governments, many companies in terms of providing this software that many people recognize as very similar to Google Maps. But we are Google Maps on steroids in terms of the analytics that we provide behind just the push pins on the maps. And also dealing with all kinds of what we call content or data sets. And that includes climate data sets, particularly with regard to public safety. Now, a lot of the work that I do also is exploratory in nature in terms of really exploring the ocean. My degrees are in geology, oceanography, and also geography and marine geology. So I'm involved with a lot of initiatives, and my company and my university are involved in these initiatives to map the unknown parts of our planet, especially the ocean floor. And the ocean floor is critical. The ocean floor is critical even to the 200 Zoom attendees here, because 99% of our internet traffic goes through submarine cables. And in terms of understanding the character, the dangers, the topography of the ocean floor, this is a huge issue. And it's also a huge issue in terms of foreign relations, foreign policy. Recently, I was even in a submersible that went to the deepest part of the ocean floor, to Challenger Deep. So I was on a dive that went to 10,900 meters. That's as deep as you can go in the ocean. It's nearly 7 miles. And part of, I think, my remit as an ocean sustainability science envoy is to, along with the State Department, help the nations that the State Department is partnering with to understand the true extent of what their country is. Recently, I was, my first, and I'm just starting the Science Envoy program. Steffi is much more advanced. She's been in the program longer and has done more trips, so I'm looking forward to hearing about her experience. But I was just recently in Cabo Verde, a small island developing state off the coast of Senegal, just last month, and that was my first envoy trip. And one of the things that the government ministries there are trying to understand is really, what is Cabo Verde? They know that 99% of their country is ocean, but what does that mean? If you look at a map, and if you look at the boundaries that are on that map, you're really only seeing the surface. And mapping now can take us from the surface of the ocean all the way down to the ocean floor, to the depths, and all of that belongs to a country as well. So how does a country really understand the resources that they are to be sustaining and managing? How do they understand foreign actors that may be coming into that part of their country that they can't see, that they don't understand? It could be something that is deployed underneath the waves. How do you understand that and work with that and manage that and use that especially for the blue economy? My recent trip the theme was the blue economy, which is fishing, shipping, transshipment, the whole idea of these submarine cables, understanding the fisheries landscape in terms of illegal, unregulated, unreported fishing, understanding coastal hazards in terms of sea level rise. All of that is part of what we're calling the blue economy. That's important across all of our different nations, and it's certainly an important part of how the United States relates and has partnerships with other countries. And then there's, of course, the green economy. Much of the blue economy is powered by the green economy, mainly in terms of wind power, solar power. Now there's wave power. Fusion energy, I think, would be part of that. So I think that's how I was drawn into the program. We've been asked how we were chosen as envoys, and we can't tell you how we were chosen. We were just called into duty, and very, very happy to do so.
Well, thank you. I'm sort of like getting a MacArthur Genius Award. A phone call comes out of the blue. First you wonder if you're being pranked, and then you realize it's a serious program and a great honor to be selected. Steffi, you want to tell us a little bit more about your work, why it is of such interest in terms of the intersection of science and foreign policy, and some of the trips you've made, and your role as a science envoy.
Yeah, thank you so much, and thank you for the invitation and joining us all here today. It's an honor to be here. So I'm going to dive a little bit into what I do. I said I heat things 10 times hotter than the sun. So fusion energy, at the heart of what it is if you look at what's happening in the core of the sun, it's fusing heavy forms of hydrogen together to release a lot of energy. And so we're trying to harness the power of the sun for here on Earth. The sun uses gravity, works really, really well there. You also have to be a bit more clever here on Earth. So to get these particles to fuse together, we have to actually give a lot of energy to get them to come together, and you have to input that energy. We also have to be very clever, because when a fuel is that hot, it's actually 100 million degrees to 200 million degrees. You have to make really clever bottles. So my research group, we make magnetic bottles to really confine this really hot matter. When it's in this state, it's actually called a plasma state. And the other way you can do it is by shining a bunch of laser beams on the fuel to impart a lot of energy to get them to fuse together. So those are kind of the main ways. And why now for fusion, and why there's a fusion science envoy? Back in 2022, there was a really huge breakthrough in my field. Have you heard of the National Ignition Facility, or NIF? I see some shaking, yeah. That's actually a laser-based fusion facility in California, and they showed for the first time controlled fusion here on Earth was possible with lasers. They pointed all these lasers at this hydrogen pellet. They actually reached those conditions we call ignition, where it starts fusing the particles together, and then you start getting self-sustainment of that reaction, as long as you're putting that energy in to confine it. So that really launched a lot of what's going on in the government, saying we've actually shown here on Earth controlled fusion is possible. Now let's tackle the remaining challenges so that we can bring this power to everyone in the world. A lot of conflict is around access to energy resources and energy in general. So if you look at powering our future with hydrogen, how transformative could that be for geopolitical aspects around the world? The other thing is, if you look at how energy dense fusion is, if you're going to use the fuel from fusion for 1 kilogram of fuel, it's 4 million times more powerful than burning the same kilogram of oil. That could be game changer. I like to use this to power your lifetime for fusion. You just need to take heavy hydrogen in 2 bathtubs full of water and use the other input is lithium from 6 laptop batteries. Everything in your life, yeah. So yeah, exactly. So that's really what we do. In my group, we have our own magnetic bottle. It's called a tokamak, and we look at transformative, innovative technology that could be used to start up future fusion energy systems. Our technology is very compact. It looks like a lightsaber. You see these ribbons, right? And it's really interesting. The way I got into this field was I have a background in nuclear engineering and physics, and then a graduate degree in plasma physics. So it's both the combination of that, the application, that engineering side, combined with that foundational physics. And so what's happening, I mentioned that breakthrough. I was actually asked to speak at the White House around that time about the next steps in commercialization for fusion. And then just last year, Special Climate Envoy John Kerry at COP announced 5 pillars of international engagement, because we do want to bring this energy to everyone, and it takes a global effort. And it's really focused on, shared research and development infrastructures, building that global supply chain, that market need, building that diverse workforce, and then public engagement and education. And so I hope as my part as the envoy, I would like to help further that, and that's looking at what countries haven't we been engaging historically, that we could really start those early conversations that may lead to bilateral agreements that then bring more people into this conversation, because it is really a grand engineering challenge, and we need more fields to come in and join us. I've gone on a couple of envoy trips so far. One thing that we were talking about that's really interesting is they ask you where you need to go for your field. Like, they have some idea, but they're like, we want your input on where are transformative ways that you can engage globally to help move your field to the next stage. And so I went to Italy. I was teaching at a school there, and we're not only envoys for our field, but also for science in general. So I met some physicists in an adjacent field, and we talked about a lot of shared struggles that we have and challenges about resources in our countries to continue our experiments, the brain drain that's happening in a lot of countries. So how can we help support that country to build up that infrastructure so people don't leave, and so they can build up that in their area? And then also, my field is interdisciplinary too. And so these were nuclear physicists that work with particle accelerators, and they're like, why are you talking to us? You're in fusion. And I'm like, because you have very specific expertise that excels ours, and how do you accelerate particles for this specific need that you can apply to fusion? And I think we kind of miss that when we work in our fields and how we're educated in these, niche, these silos, and bringing more people into the conversation really drives that innovation forward.
Thank you. It's interesting because, clearly the kind of depth and breadth of expertise that you both bring to your work and to the State Department's work is extraordinary. And the State Department has, over now, quite a number of years, been trying to internally strengthen its focus on science and technology and bring in more people with those kinds of expertise. But clearly, they cannot have the kind of expertise represented here routinely within the walls of the State Department or in our embassies around the world. So to be able to have access both to what you know, but also your networks is crucially important. I do want to pick up on what you said about your role in sort of addressing some of the challenges to science, along with addressing issues that need to be better integrated from science in our foreign policy. I mean, when this program was first started, it's probably fair to say that the world was a slightly calmer place, a somewhat more stable time. I think the geopolitical context for your work is getting more complicated. The world is increasingly polarized. There's been a rise in nationalistic politics and authoritarianism. There's been growing conflict and distrust between countries and regions. There's been growing distrust in science and scientists and scientific expertise as well in this country and in other countries around the world. So I think it's fair to say that sort of the landscape now in which you have to do your work is a little bit more fraught. Where science and diplomacy meets now is more volatile and complex. And so I would say along with that, as part of the change in geopolitical context, we've gone from a time when I think there was really enormous hope and emphasis on scientific cooperation and the recognition that science at its best was a global enterprise, to a recognition that there are a lot of elements of science that are highly competitive, and there are economic issues at stake, and also aspects of science and technology that have very direct bearing on issues of national security. And sometimes those come up against certain scientific fields of endeavor. It's interesting to me, in a way, thinking about each of you and your domains of expertise. The climate change area and environmental issues will only find sustainable solutions through true cooperation and a comprehensive approach, in my view at least. The fusion area is a complicated area because it requires big equipment, big science, often the costs of which require sharing across nations. But it also involves intellectual property and tools that are just, hugely important to individual countries in terms of economic issues and security issues. So I wondered if each of you could sort of reflect on the changing terrain in which we do science and how that intersects with international interests and activities.
Well, I think one thing that's interesting about this Science Envoy program, and both Steffi and I are in, our activities are under one bureau of the State Department, which is, it's called OES, but it's Oceans and International Environmental Scientific Affairs. So even though our fields are quite different, we're in the same bureau. But there are many variations on the theme that are possible. So for instance, my Envoy experience was very different from Steffi's because I was asked to join an existing delegation. So the State Department has this Office of Global Partnerships, and I was asked as an envoy to join 12 other individuals who traveled with the State Department to Cabo Verde. And the idea, and this was science and technology, but it was also finance. There were several financiers, venture capitalists who have their own businesses and are looking to invest in Cabo Verde's industries, particularly in the areas of aquaculture, other fisheries, ports, shipping. So we had a broad range of activities where we toured many of the businesses and the government ministries and the NGOs of that country. We discussed all of these different issues, such as the blue economy issues in these areas, climate change, also ocean science and technology research. We had a broad variety of activities, and it was up to us in the delegation to forge partnerships. It was sort of like a birds of a feather. They took us around the country for birds of a feather sessions. And if that particular company or agency or university lab resonated with what we were doing in our own organizations, then we had a venue, we were right there, and we had a chance to talk with them about, whoa, let's work together, let's go in on this project together. For some of the financiers that were part of the delegation, I want to invest in your company, let's start with an MOU. So it was very fascinating. I'm not sure if the other science envoys are having this experience because it's so varied what is possible. But this particular delegation was going forward at this time because there is a current partnership for Atlantic cooperation. And there are 42 countries that surround the Atlantic Ocean that are part of this cooperation. And Cabo Verde, of course, is one of those nations. So that was my assignment, to be part of that delegation. And then I had a separate day to meet exclusively with an NGO, a nonprofit that works on shark, sea turtle, seabird conservation, and is also in need of mapping technology or science communication technology to talk about the amazing work that they're doing. So I had an opportunity to work exclusively just by myself with them, as well as with a few professors at the University of Cabo Verde. So that was also very, very gratifying and fun, because my company and this nonprofit will now be working together. Then another ingredient in this is that those of us on the delegation, we are now partnering with each other. We've had a chance to learn about each other. With my company, there was a natural linkage with the scientists from the Woods Hole Oceanographic Institution, who is part of the delegation. There is also a blue economy cooperative out of Rhode Island that my company and I will be working with. So very hopeful, very productive in terms of not just a one-way street, but also in terms of opportunities, and that's why it's called a partnership opportunity delegation, to partner with that particular country, but then also to partner among ourselves. And I had no idea that the State Department did this kind of work. So it was really eye-opening in a wonderful way.
Great.
Yeah, your question touched on a lot of things, so I can cover a few aspects of that. I'm going to start first on kind of just like a really high level of how fusion started, because I mentioned how it's that hope that brings, that drive for an energy source that's available to everyone, that really transcends, continents, countries, and things like that. And fusion was really born in diplomacy for science. Early on, when they declassified the research for fusion, that's when people started working out in the open and collaborating globally under, global umbrellas for collaboration. And then in this top-down support for fusion really kind of took off in 1985 with a joint statement between Reagan and Gorbachev, who advocated for the first time for this international collaboration for fusion, because we do need that large infrastructure that not one country can come together and do. The other example that you familiar with it for space, the International Space Station. Well, around that time, they actually started ITER. It's the largest international collaboration. I think there's more nations and money behind it than the International Space Station. They're building it. They started construction in 2000. It's in southern France. And the partners for that device is China, Euratom, India, Japan, Republic of Korea, Russian Federation, and USA. So everyone, all those nations can work together. That means it's an enormous project, and it takes a lot of time, right? So we're doing a lot of things on the side with bilateral and multilateral agreements to work on these shared facilities. But I think that's a really good example of how countries can come together and transcend everything for science, for the greater good. And then along with the polarization that, you're worried about the trust in science, another research group that you mentioned was looking at those interdisciplinary aspects of commercialization of fusion. And part of it is we actually engage communities and we ask them, what values do you have and your communities that come into your energy choices today? And we have these, we say your lived experience is experience, and we need that knowledge. We pay people, we hang out with them for 8 hours, we feed them, and we have these amazing conversations around energy that they never had before. And then we've had some follow-up interviews asking people like what that experience was like for them, a couple weeks after, and they're like, I can't stop talking about it. Because in a world where I just can't stand the people that I stand next to in the grocery store, I could sit next to people for 8 hours who I knew had these opposing political views, and we found commonalities. We had shared values, and you gave us that space. So that was really amazing to me to be a part of that. And then along the public-private partnership and shared parts of that, I was part of the U.S. delegation that went to Germany. And we brought a bunch of people with us from the U.S. side, and we toured a lot of amazing facilities that they have, from publicly funded to public-private partnerships, all in one space. and actually, the commercialization application. And so we learned a lot from that, from Germany. And then we found at the end of this week, because we were traveling all through Germany, we'd just show up at a lab with our luggage, go through everything, get on a train and go to the next city and things like that. And then at the end, we kind of talked about what an agreement would be between our countries and what did we learn from each other from that experience. And that was fascinating. And I also like talking to people on the US side that you wouldn't have to build those partnerships. It was really amazing. And then to be an envoy as part of that delegation is it was surprising to me because they bring an envoy because there's not very many that are selected. It's usually the science and technology fields that are elevated at that time. And so when the US comes with an envoy for your field, you're like, fusion is this important to the US government that we have an envoy and we brought them here.
Do they give you any training before you start on your missions?
Absolutely not.
So sometimes we work on an engagement plan, and they'll give me the historical context of policies they may impact the development and deployment of fusion in that country, and then they'll be like, and this is really important right now, academic research security, and then I'm like, I don't know what that means. And so then I get to talk to someone at the State Department who tells me what academic research security is. So they're really great about supporting, if you have questions and things like that. Yeah.
We are briefed, but it's up to us to have the science communication, the science diplomacy skills, and to jump in and participate with these delegations.
One other thing that I just want to touch on, and I want to be sure to leave lots of time for questions and answers from the group, but the context for science has been changing, and obviously lots of different pressures, competing priorities in terms of investments in science and technology, and also the concerns about public and governmental trust in science and really the use of scientific expertise in critical decision making. We've been talking mainly about sort of academic science in many ways and government, but the world of science now really has shifted a lot, where the partnerships of academia, industry, and government are increasingly important, and I think both of you represent that in your work, and I'm wondering how that's reflected in your science envoy work, and who's at the table and who you engage with, and does it make it easier or more complicated in some ways to have some of these discussions?
Mm-hmm. I think the hope is that the public-private partnership that Steffi mentioned, that it will make everything go faster. And I think that's one of the things where academia is starting to wake up to that now. Even in terms of the way that both of us were trained and the way that we are participating in this particular program, which is something that I think was unheard of 20 years ago or so. And the idea, now I've only been on one trip and one delegation, but the idea there is that you need that ingredient of the government ministry, which can often provide the funding, the scientists and the technologists who can provide a solution, along with maybe a nonprofit or a community. And it's very, very important, this idea of community science, indigenous science, especially for community resilience. And with my area of ocean sustainability, this is critical. I think this is why this is elevated in the U.S. government, because we see this along our own coasts with how so many communities, we just think about the recent hurricanes, Helene and Milton, and how that has devastated so much of our infrastructure, our economy. We've lost so many lives. And then you take that to a small island developing state, and it's just amplified exponentially. And one of the reasons that Cabo Verde, which is a very small country, 10 small islands, about the size, if you put all those islands together, they are the size of Rhode Island, in terms of with them spread apart in their and this is National Geography Awareness Week, so I'm very happy to be explaining this. With the way that the islands are situated, that whole area is about the size of Texas. But that very small nation is really responsible for a lot of the transshipment. We get a lot of our seafood because of Cabo Verde. The Chinese send their fish to be processed there, and then in turn that goes to New England. Many of the hurricanes that are born in the Atlantic are born right on their doorstep. So our monitoring of those events starts with Cabo Verde and with their Institute of Meteorology. So all of this is very extremely important in terms of making these types of connections.
Thank you. Steffi?
Yeah, and to the public-private partnerships, I think our field Fusion's trying to rapidly accelerate. And so they're trying to see what are key strategic partnerships that we can start now. And so with that becomes, how are we navigating the IP and things like that. So there's been a lot of work in the academic side of, suddenly we're thrust into this situation where we have to start thinking about IP and navigating the public-private partnerships and working with our universities on how to do that. So a lot of us are working on that, and I've had several private companies where we're talking to them about how do we kind of think about developing and deploying our technology on their devices, because they're very interested in it. So with that comes a learning curve, and so bringing those resources to the table early on is very helpful, which is why it was so great to learn what they're doing in Germany on that side for other sectors. And then I think it's important too to remember, back to the engaging the communities too, the private companies and the communities' values and what they want are aligned really well, actually. They both, I'm going to use the energy side, they both want access to energy and the value and the what that brings to their lives, and they want it to not infringe on their way of being and their way of life. And so the earlier that you can bring these sectors together, the faster you can actually deploy technology into society, especially for something that's so large as well.
Great. Well, I do want to go to questions and answers from the audience, and if you're joining us virtually, you can start to get your questions ready. But it is striking that this is the first cohort of Science Envoys that's all women. I think we all recognize that issues of women in science, in academia, industry, and government are still of concern, that full gender representation and gender equality, is a goal to be achieved. I am interested in both your experiences in your careers, but importantly for this session, is this a topic that scientists around the world bring up with you, since you are outstanding and representative scientists who are female, when you go out and engage, or is it not a topic that is part of your large array of highly technical and scientific deliberations?
Well, I think for me, I think both Steffi and I hope that we all of us hope that we get to the point where it's not an issue, where we don't have to talk about the first woman. Or I'm doing a lot of work right now in outreach to communities because I'm the first person of African descent to go to the deepest part of the ocean. That's wonderful, but I want that to be a non-issue at some point. And I think now I'm in the geosciences, so it's a huge issue in the geosciences, geology, geophysics, geography, ecology is part of that as well, in terms of women still being so poorly represented, especially at the senior stages, those of us who are full professors or deans or provosts and so forth. Cabo Verde was a very fascinating country to visit because they were not looking at those. They don't think the way that we do. Even with Cabo Verde being an African country, they have their background is so richly tied to Portugal. And there's so much intermarriage there and so many different hair textures and skin colors. I grew up in the Hawaiian Islands, so I was in heaven because that type of multicultural, they did not make an issue out of those of us who are women in the delegation, or even two of us who are black, who are part of that delegation. They were like, welcome. We are glad that you're from the United States. We want to talk about how we can partner with the United States. And in a way, that really, really was a wonderful lesson, very refreshing to be in that environment. But I think that the issue of women in STEM, science, technology, engineering, math, and add the A in there for the arts, is an ongoing conversation that we're going to have.
And Steffi, you're in a domain, physics and engineering, where historically women have been significantly underrepresented. So, as a role model, obviously, I'm sure you have made a difference.
So our field is about 11% women in the U.S. So it's a struggle when you're the only one that has similar shared life experiences, right? And then you're trying to fight a system that is actively fighting against you. And so then it's, building community where you are, building a sense of belonging. And so I've always tried to do what I can in my part to find people to help make things better for me and others. And then sharing that, just like Dawn mentioned, I didn't get it when I was going in the delegations. You're representing the U.S. But when I was going and having like one-on-one conversations, then it came up with women. They're like, "How many are in your field, in the U.S.?" And they're in Canada. Was surprising because they had even less. And I'm like, "Oh, this is bad." And they're like, "Yeah, this is bad. What can we do here?" And to the part of like representation matters.
Yeah.
So I think like the fact that they pointed that out, that matters. That sends a signal right there. My group, I'm a PI of a group. It's like 20 people.
PI means principal investigator,
I'm
by
sorry.
the way, in this context.
Thank you. It's 60 to 70% gender minorities. And I did that in 5 years, I think. And that's, bringing in evidence-based practices of how do you create the climate and culture for people to thrive? How are you recruiting people using holistic admissions and things like that? And cognitive and non-cognitive skills that you're assessing too.
And I think it helps, just a quick addition. There are 4 of us in this cohort. So the other 2 science envoys, Dr. Ruman Chowdhury, she is an expert in responsible use of AI, artificial intelligence, ethical artificial intelligence. And Dr. Cyan Proctor is also a geoscientist. She was the first African American woman to pilot a civilian spacecraft. And so her area is civil use of space. So those are the other 2, so there are 4 of us.
Interesting, interesting. Well, I think we need to get on to questions and answers from the audience. I actually told Mark Alexander, who has, as I said, the vision and commitment to sponsor this new series, that he could have the first question.
Thank you. Thank you.
Oh, and let me just remind everyone that this session is on the record. So just, keep that in mind when you're asking your questions and maybe when you're answering them too.
Thank you. No, I just want to say you had mentioned that it was an honor for you folks to be here tonight, but frankly, from the foundation's perspective for this inauguration, it is our honor for you to be here. So I want to thank all of you for being here and participating in this inaugural event. My question is a little bit more particularized and probably segues into a few things that you may have mentioned. And it's given the upcoming administration's position on such things as global warming and vaccines, I'm wondering what impact you foresee this may have in terms of the program itself in terms of impacts on the envoys, in terms of their attempts to continue with their collaborative efforts. So perhaps you could respond to that. Thank you.
You want to start, Dawn?
Well, Steffi's been in the program longer, but I think we both received the same messaging from the State Department that the Science Envoy program is nonpartisan and that it will continue. It continues. It has continued regardless of who is in the White House. So we don't know what the future holds next year, but we are totally expecting to continue our work. The State Department is arranging for me to go to Seychelles and Mauritius in the Indian Ocean, given that my emphasis is on small island developing states and ocean sustainability. So that planning is in the works. And it's just wonderful to know also, we've both been told that we are private citizens that are working with the State Department. So we are not employed by the government. We do not even represent the U.S. government from that standpoint, and we are allowed to say what we think and what the rigor of our discipline has taught our field, what the latest results are, what the latest best science and engineering is that we are involved in.
Yeah, I think you hit a lot of the really important points. So I'll kind of talk from like what I look at it from my field, right? It's energy security. It's trying to find partnerships to accelerate the science forward, to make people's lives better, and making sure that I always focus on that and ground that and really listen to international scientists on how can we help make their lives better. Help make them be able to do their best science where they are too. I mentioned energy security, but you can also look at fusion for desalination. So I'm looking at going in, I'm planning trips, my future trips too, to Latin America and the Global South and North Africa to see if there's partnerships we can build there.
Well, we hope that the program will continue, and there's a lot of work to be done. Let's see, the first hand I saw go up was in the back with the lanyard. And then I'll try to, quick questions and quick answers, and maybe you both don't have to answer every question as well.
Thank you. I'm Jonathan Panter. I'm the Stanton Nuclear Security Fellow here at the Council. It seems like we live in an age of innovation, but we also live in an age definitely of international mistrust. Both of your fields are highly relevant to national security endeavors, be it energy security, underwater cables, mapping the ocean floor relates to anti-submarine warfare. And we've seen an increase in the past few years, certainly in export controls of critical technology and greater scrutiny on Chinese scientists studying in the United States. How have both of you witnessed, if at all, any of the national security downstream implications of that?
Steffi?
Sure, I can just really quickly how it's impacted us. Just more recently is having to disclose where all of your funding is, where are all of your collaborators, and which technology that you're developing and using. I used to work at a national lab before I took this academic position, so I knew about the export control and things like that. So it's getting primers on that and making sure you're doing things appropriately.
There are a lot of concerns in my area too, particularly with regard to watching what's happening in the South China Sea and those tensions there, very concerning. Also, the difficulty that we as ocean scientists and explorers often have in getting permits to do our research, or it's not just our research, it's collaborative, multidisciplinary research with many countries involved. It is very, very hard to get permits to operate in exclusive economic zones, the areas that are 200 nautical miles out from the territorial sea boundary of a country. There's also the issue of deep sea mining as well. And I'll just say deep sea mining and leave that there because that's a whole other seminar.
Right. Let's see, this woman here.
Hi, Miriam Safi. I work at the State Department, so it's really extraordinary having you here. I'm in the Bureau of Cyberspace and Digital Policy, where we work on subsea cables. My question is more on sort of institutionalizing what what, from your perspective as someone from the outside that's inside the department and the institution, how can the State Department do more to better integrate science and technology into our foreign policy work?
So I think so I'm part of the New Voices of the National Academies. It's kind of like their younger academy branch. And we, for the first time, learned like how do scientists put their input into the policy space, because we're not taught that. So I think providing those avenues, making that clear, it was super helpful to us. And then there's also tools to track how your science is then informing policy, because a lot of us were, assessed in an academic enterprise that has very small definitions of what it looks like to be a scientist. And so adding that policy space and making it clear is super helpful. Yeah.
I think quickly, one of the things for me, I work for a mapping company, and my company does support the State Department, but we're finding that with foreign policy, you've got to have good maps. You've got to have good data. You've got to be able to make maps that are prescriptive and predictive with how quickly conditions and migrations and things are changing across the world. We have the technology to do that. The State Department has that technology, but it is siloed in certain bureaus. There is an office of the geographer of the State Department, but even in terms of the bureau that Steffi and I work in, one of the side projects of my envoyship is working with others in my company and others across the State Department to take advantage of the mapping technology, the mapping capability that is already available to the State Department, so they can optimize that. And every bureau has the same ability to do these maps and these spatial analyses.
Great. Looking to this side.
Thank you. My name is Aaron Mertz. I work at the Aspen Institute. I'm the founder and executive director of our Science and Society program. And thank you, Peggy, for being a founding member of our advisory council. Grateful for your service to us. My question for you both is, we work across intersecting pillars that include public trust in science and global science. Can you help me bring those two together and identify any trends that you've observed from your envoy work or other work abroad where you've seen public trust in science issues manifest differently from how they do in the US, which are usually centered around institutions and elite organizations like universities? How are things different abroad?
Thank you. An important question that we were discussing a bit before the session began. I think both of you quickly, I mean, again, this could be a whole other seminar.
Do you want to go? You can go.
Well, I'll just go quickly. I've had less experience as an envoy, but in terms of international scientific collaboration and going to different countries, especially to do research projects or public-private partnerships, I'm finding that the trust in science in these other countries is a bit more elevated in these other countries, and that the erosion of trust in science, I don't want to say it's an American phenomenon, but it's something that we do have an issue with here in this country. And I think it's one of the reasons why one of the trends that we are seeing in this country is the importance of science communication and escaping the ivory tower and being able to communicate your science in terms of, as Steffi has said, making people's lives better, communicating with policymakers, communicating with journalists, not to be afraid to communicate social media to help build up that trust in science. I mean, this is a trend that is international, but I certainly see this in the United States in terms of certificates and degree programs in science communication, and science communication being part of your promotion and tenure record as well, which I think is a very good trend.
That makes a difference.
Yeah,
Steffi.
for my field, we went to a couple countries in Europe, and it was just pretty impressive how they're able, from a governmental level, to be like, this is our clear mission, this is what we're building, let's go. And then they have full facilities that are dedicated to supporting that one mission, and they even call each other like one team. We're all one team. Where in the U.S. we see a lot of diversification of like processes of how we're trying to realize fusion, and maybe there's not as much streamlining for some of those really big challenges that we see in other countries.
You know, it's interesting. I did just see a poll that Pew, that trust in science in the U.S. has increased a bit. The trend had started before COVID, clearly exacerbated with COVID in terms of lack of trust, but a little bit of hope that we're improving. But I think, you know, many of the strategies that you mentioned are going to be important going forward, and it's so fundamental to being able to really translate what we can offer in science and technology to people in decision-making roles. Oh, I think I need to go to our virtual audience. Olivia was signaling me.
We'll take our next question from David Gilmer.
Hello, yes, Daniel Gilmer here, CFR term member working in the pharma sector. Thank you for hosting this insightful inaugural session. As I'm sure you've both experienced, it often feels that the importance of science diplomacy is underappreciated. So can you elaborate on the inevitable interconnections between science and foreign policy, especially amid potentially reduced funding for our science diplomacy efforts? How might the US and other countries be most immediately or significantly impacted by the interconnections that are increasing in fields like climate, epidemiology, nuclear, among others? Thank you.
Okay.
I'm not sure where to look for in order to communicate with the Zoom. Where should I look at the screen, or where should I look?
I think it's okay.
Okay. Well, thank you very much, Daniel. I'm not sure whether we are going to see a reduction. So I'm speaking hopefully, especially as we've mentioned before that our program is set to continue regardless of the administration that is in place. And I'm also very heartened by what's happening at the state and local levels in terms of these initiatives as well. There's so much that has happened at the state, coming from California, where we are very independent in terms of we move forward and fund things. Maybe Wisconsin is similar. So I'm going to answer with just hope that we can continue our work and move forward, and we'll see what happens in 2025.
I think it's important that in our education systems we start teaching in science the diplomacy, the history of diplomacy, how it impacts on a global scale, but also how civic science can be impactful at the local level. I think those are super important. I'm an engineer, I don't have to take any poli-sci classes. This is amazing. Oh. And now I'm like, oh, that was a big mistake. That was a big mistake. And so bringing that in and how it's important throughout.
Great. And demonstrating value of science
Yes.
in people's lives, I think, is important.
Yeah.
Yes, the gentleman there up front.
Thank you very much for these insightful comments. My name is David Braunschweig, and I have a question for you, Doctor. You mentioned the importance of oceans for fisheries and for various other uses. There also happens to be, last time I checked, quite a lot of water in the oceans, and we tend to drink that water and use it for agriculture. So what is your position on desalination, which can be controversial from an environmental standpoint, but many countries have shown how beneficial it can be?
I think desalinization as powered by fusion energy is the way of the future. It is quite controversial, though. And one of the issues that we have faced in Southern California, especially with our continuous drought, we have desalinization plants. We are trying to move those plants off of fossil fuels. So if there is a way to power these plants in a green, clean energy way, I think it can still be a useful solution.
Let's see. Gentleman with the tie there.
Tim Stearns, Rockefeller University. Thank you for the really thought-provoking remarks. My question has to do with thinking about scientists advising governments about science policy, and it's the question of how one manages expectations. You could view it as the danger of overpromising. This might be most applicable to the fusion question. And so the success of NIF in achieving what it has been remarkable in how much enthusiasm it's generated for fusion energy. But the director of Lawrence Livermore has been very, I think, forthright in highlighting the challenges of bringing that to economically viable fusion energy. And it's pretty clear that although we're beyond the old joke about fusion of being it's only 10 years away and forever will be, it's still true that there are a lot of technological challenges to go. So how do you manage the expectations of policymakers in a field where there's such promise to solve one of the truly difficult technological problems facing the world, and yet we really are far from a viable solution?
Yeah, thank you so much for your question. It's super important. I also love how you said we're only 10 years. Usually get 40 years, so thank you. I think it goes back to telling people what the challenges are that we need to overcome, because that's something concrete. That's something you can point to, and that's something that you can point to how much money it takes, right, to retire that risk, instead of just promising timelines with nothing kind of putting in the context of what that takes. Because we really do need those drivers, that money, the policy to move things forward. And to the policy part, we're seeing on fusion is harmonizing regulatory frameworks around the world that are more inclusive of developing technology while keeping human safety at the center.
Great. You may be the only bow tie in the room.
Why, thank you. Henry Breed. Dr. Wright, you were speaking about your work in the Seychelles and in Cabo Verde. You've worked with other SIDS. For some of them, this is not merely an environmental crisis, it's an existential crisis. What special perspectives on those interactions can you share?
Well, you're so right that the SIDS, or the small island developing states, come at this indeed from we are not going to have anywhere to live. And where can you help us to invest in sea level rise monitoring? Can you help us to invest in our community health issues? Because the climate change that these countries are experiencing, it's a health issue in terms of the extreme heat. Cabo Verde right now is going through an unprecedented drought. In addition to the sea level rise issues, but in terms of the heat stress that they are experiencing, can you help us to map this? Can you help us to find suitable places to move our communities to? Can you listen to us as we talk about these issues, that when we try to solve these issues with your technology, it does not work because your technology has been developed from a Western perspective. So it's a two-way street in terms of we are trying to listen to their stories, to their issues, so that not only can we provide our science and technology to them, but they can help us to improve our technology. In our mapping company, again, just focusing on that, that's what we really focus on in terms of research. And I mean, it's a research and development issue for us as well.
Great. I think I saw your hand has been up for a long time, yes.
Hi, my name is Hall. I work for an elder mental health company called Cogensis. So I have a question about funding, since this conversation started about funding. Can you just give me some perspective between the past few years? What has the conversation been about where dollars are going for science, whether it's federal government or private investors? And what do you think the prognosis is where we'll be going forward? I'm just thinking about, what priorities are being focused on and which ones are maybe sent elsewhere.
Well, I can say quickly in oceanographic science that it's been quite dire. 95% of oceanographic science requires very expensive science in terms of research vessels that need to be deployed at sea at a cost of around $50,000 per day. The National Science Foundation has been the primary funder of that type of science, and that has eroded over the years across both kinds of administrations. So we're seeing philanthropy, these private organizations such as the Schmid Ocean Institute and the Paul Allen's outfit, and there are many others. In fact, one of the members of the delegation that I was in they are Ocean X, and these are the types of organizations that, through their own private funding, are deploying research vessels and equipment for the scientific community to use. So it's another avenue to get this type of science and exploration done. So that's one trend that I think is going to continue.
Yeah, we're starting to see, a lot of investment on the private side. There was $8 billion just in the past 5 years. I know that's not a lot, right? But that's a lot to us, where we're not used to seeing that private investment, and we're still lacking those large investments in critical infrastructure that's maybe not an actual fusion device, but it's something to help you test materials. It seems a little bit more boring, but it's still critically necessary. So I think exploring those, similar to what Don was mentioning, is important for fusion too.
If I can just editorialize slightly, when people talk about science diplomacy, they often talk about it in terms of 3 types of science diplomacy: science in diplomacy, diplomacy for science, and science for diplomacy. I think that right now, all of those are important, but all of us need to be diplomats for science. This is a critical time to be able to advance key areas of science and technology, to be able to increase our knowledge and understanding, and also to make sure that that gets really applied in critical areas to address unmet needs that matter to this country and to other countries. And we cannot take for granted that the engine of science will continue to move forward at the amazing pace that it has, with the amazing products that it has produced, unless we continue to invest in science. So I urge you all to be diplomats for science. I think we have time maybe for one last question. Yes.
Thank you. I'm Henny Sender with BlackRock, and my question is a bit cynical and a bit messy, so please forgive me. But Robert Oppenheimer went to my high school. I lived in Japan for many years, so I spent a lot of time thinking about how science is used in a world where it has massive implications both for peace and its opposite. One of the things, the word that kept occurring to me listening to both in this fascinating discussion is about trust. And it just seems amazing to me that trust transcends everything when I listen to you. But I also wonder, I spend a lot of time in Asia, which is ground zero in a lot of ways. And, I listen to people in the developed world saying, well, so what if sea levels are rising? Amsterdam is just fine. But Bangladesh doesn't have the means to achieve that resilience. And I wonder, to what extent do you worry about fragmentation, that the developed world has created a lot of problems, but emerging markets are paying the price for that? And when I listen to debates in the global south, so much is cynical about a lot of international organizations. Very messy, rambling question.
And
Forgive
we're out
me.
of time, and CFR is very, very insistent on stopping on time, so I'm failing in my chair role. But so if you want to offer some very quick observations on a really big question.
Very quickly, thank you for that question. And I'm thinking about COP29 right now. We are seeing it COP29 in terms of the climate financing, and the developed nations cannot get consensus and cannot move forward and make progress on paying for helping the global south and the developing nations with climate resilience. We are not making enough progress, which is why I think science diplomacy is so important. We have to keep pushing forward.
If we can end on that. That's good.
Okay, well, I think we'll end on that. Join me in thanking our panelists. And thanks to all of you. I think we've had, this has been a demonstration in action of why science diplomacy can matter. Again, thank you to Mark Alexander and this recognition of his father in a critical area for all of our shared futures, bringing science and technology more closely together with foreign policy. So thank you all. Please note that the transcript and video of this session will be available on the website. And we look forward to this continuing forum for discussion and the work that can and must go forward. Thank you.